Once we've developed a sound experimental design and collected some data, we need to interpret our results. One key tool we use to do so is statistics. So in this video, we'll talk about descriptive statistics, which are used to describe characteristics of our sample. We're first interested in looking at the central tendency and the variability of our data. The central tendency gives us information about the middleness of a distribution of scores. Often we use a mean or a median, and less often a mode. So you're looking for some sort of average value to give you a more global perspective on your results. But a single average value doesn't give us that much information. We also need to know the variability of the data. This is the width or the spread of the data distribution. In other words, if we're using means, how are scores dispersed around the mean? So here, if we show some sample data, we have test score on the x-axis and frequency of the score on the y-axis. We have two different distributions. In red, we have data with small variability, so the scores are clustered near the measure of central tendency. In blue, we have a wider spread of data, so this is a larger variability. The scores are more spread out around the central tendency. So these two data distributions have the same central tendency, or the same mean in this case, but different variabilities, different spreads. So in blue we have high variability, and in red we have low variability, and we see this represented visually by the width of these curves. We can report variability in two ways. One is the range, and this is just the range of values from the minimum to the maximum. It doesn't tell us much about the distribution of the scores because there could be outliers that are way outside of where most of the scores are clustered. The other, more informative way is the standard deviation, and this is the average distance from the mean of all the data points. So we take the distance from the mean for each data point and average it. So let's see what different standard deviations look like. So here's a chart showing metabolic rate for females and for males. So we should have metabolic rate on the y-axis. We want to make sure we include our units here. On the x-axis, we have our female and our male sexes. For female, we can draw some data points, and for male, we have some data points. And this red dot here is the mean of the data point, and our standard deviation is about 421. For males, we have a similar mean, but the data are spread out much more, and our standard deviation here represents that as 894. So here you see what different standard deviations look like. The data become more spread, which means the individual data points' average distance from the mean is greater. So we can use these measures of central tendency and variability to assess our measurement tools. How good are the metrics that we're using in our research? So we look at validity. Is our metric providing an accurate measurement? So here we have this bullseye, and at the center of the bullseye is the true value that we're trying to measure. And these black dots are our measurements. So using our noisy measurement tools that have some errors, we get measurements that aren't exactly matching our true value. But the measurements, again the black dots, are close to the true value. And so we call this a valid measure. We say it's somewhat accurate. It's getting, on average, it's picking up what the true value is. So this is an accurate measure, so we call it valid. An example would be if you step on a scale to weigh yourself 4 times, is the average of the numbers reported close to your actual weight? But here we have some results that are not valid. The mean of the measurements is not near the actual value, the center of the bullseye. But the measurements are at least consistent. They're clustered close together. So we say that this metric is reliable. It provides consistent measurements over time. So reliability tells us if we have consistent measurements. For example, if you take the SAT or ACT over and over again, are your scores always similar? If they are, then this would be a reliable measure. Ideally, we want the metrics that we use to be valid and reliable. Once we've determined the central tendencies and variability of our data, We move beyond these descriptive statistics and we start using inferential statistics to figure out if these differences and relationships that we observe are real or if they're just due to random chance. So if we have mean A equal to 100 and mean B equal to 108, we want to know if the true values are actually different with reasonable confidence, or the results we observed are just due to variability. So we use inferential statistics to make inferences about whether the outcome observed in our limited sample would occur in a real-world population as a whole. We'll dig into inferential statistics more in class.